Now I am going to solve a transcendental equation using the method bisection. Using the method bisection. So here, suppose I want to solve an equation x minus cos x is equal to 0. X minus cos x is equal to 0. First, we find two values a comma b such that f of a and f of b are in opposite sign. So there is intermediate value theorem. So the background of this bisection method is the intermediate first condition is f of x is a continuous function. If f of x is a first condition for bisection method is f of x should be a continuous function on a closed interval of ab. That is the first very important condition. This is f of x should be a continuous function on a closed interval of ab. Second point is f of a and f of b are in opposite sign. F of a and f of b are in opposite sign. That means f of a and f of b is less than 0. F of b and f of b is less than 0. Then there exists means at least one element. Then there exists at least C belongs to open interval of AB. This is the intermediate value there. AB. There exists means there exists at least one element. That is the meaning. There exists C belongs to open interval of AB such that f of C is equal to 0. This is called intermediate value theorem. So bisection method, not only bisection method, all numeric bisection, interval bisection. Next is bisection. Next one is Newton-Raphson method, secant method. All are based on this intermediate value theorem. Here the condition is f of a and f of b are opposite signs. If f of a and f of b are opposite signs and f of x is a continuous function. For the sake of discussion, let us assume that f of a is greater than 0. If function value at a is greater than 0, this is f of a. 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 This is a. This is a point. Okay. So this is a comma f of a. And f of b is less than 0. F of a comma f of a. F of a, I'm assuming positive. At x is equal to b, the function value is negative. Okay, b comma f of b. F of a and f of b are opposite sign. And f of x is a continuous function. So definitely the curve may be like this. Now, since f of x is continuous, it crosses x-axis. So this is the root of this function f of x. Root of this function. This we need to find out the value c. C. At this point, f of c is 0. C comma 0. Function values. It may be like this. It may be like this. Anyway, if the curve is like this, there are 1, 2, 3, 4, 5 roots in the closed interval of a comma, in the open interval of a comma. There are 5 roots. That's why we are writing there exists. There exists means there exists at least one C belongs to open interval of AB such that f of c is equal to 0. This is called intermediate value theorem. So bisection method is dependent on intermediate value theorem. Intermediate. The first and foremost condition is f of x should be a continuous function. F of x should be a continuous function. Then only this we can apply the bisection method. Bisection method. Okay. you can apply bisection method. If you take a discontinuous function, sometimes you may not get the root. So many examples we can give: x minus tan x in the interval of 0 to pi, x minus tan x. If you take some interval, we cannot find the root, but because it is a discontinuous function, x minus tan x. Okay, a comma f of a, b comma f of a. That means you have to choose. If you want to apply bisection method, you have to choose 2 points a comma b such that f of a and f of b are opposite sides. Then after that we take bisection point. We take bisection point c is equal to a plus b by c is equal to a plus b by c is equal to a plus b by. I'm taking new slide. Let us go to the bit. Sometimes this is the problem with this. Okay. F of a and f of b are in opposite sides. F of a is greater than 0, f of b is greater than 0. Let us assume that the curve is continuous. It is like this. This is my root. I don't know this value. This is e. This is e. First we calculate c is equal to a plus b by 2. C is equal to a plus b. Middle point we take a plus b by 2. This is, let us assume this is c. The first iteration. If f of c is greater than 0, here this f of c is greater than 0, the function value at c is greater than 0. Function value at this c is greater than 0. So the root is like f of c is greater than 0. The root is lies between c and b. C and b. Suppose f of c is less than 0. F of c is less than 0. The root is lies between e's. If is coming now. If first we calculate this value, if f of c is greater than 0, if f of c is greater than 0, replace a by c, otherwise replace c by b by c. That is the first condition. Next, now we have a new root. The interval is, the root is lies between these values. Now again we take a bisection point. Bisection point. Bisection point. So this is the bisection point c. If f of c is less than g, now f of c is less than g. Now we replace b by c. Now the root is lies between this one. We continue this process until we reach the desired accuracy. This is the bisection method. So now I want to apply this method. I want to write a program for this method. Let us assume this is the function f of x is equal to x minus cos x. Here f of a is equal to f of a. F of 0 is equal to minus 1. We have to choose like this first row, a and b. F of 0 is equal to minus 1. F of 1 is greater than 0. So root is lies between 0 and 1. Let a is equal to 0, b is equal to 1. You calculate c value, a plus b by 2, 0.5. I calculate the function value at 0.5. That is less than 0. Less than 0. That means we have to replace a. In the place of a, we have to write c. A is equal to 0.5. B is 1. Here the function value is negative. Here the function value is positive. Again, I have taken c value a plus b by 2, that is 0.75. I calculate the function value. It is greater than 0. It is greater than 0. So we have to mu b is f of c is greater than 0. So a is 0.5, b is equal to 0.75. The root is lies between 0.5 to 0.75. Again, we'll calculate c is equal to a plus b by 2. Here 0.625. The function value at this point is less than 0. Take a is equal to 0.625 and we'll continue this process to get a desired accuracy. After 14 iterations, I got c value at 0.7391 and function value is minus 0.0001. After 14 iteration, I assume that this is very small value, minus 0.0001. So after 14 iteration, this is a root. Now I want to write this entire, I want to write this program. I want to write for this right hand side part. It is very simple actually. Am I correct or not? So you take a MATLAB. It is very simple program. Only we use if condition. If and for loop also. CLC. First we have to define a function. How to define the function? F is equal to at the rate of x minus cos x. Otherwise you give another function. Not a problem. I will take another function. X minus. Tell me another function. Any one function. Otherwise I will take any. You take given one transcendental equation. I will write the program. I will find the root. Tell me any. Otherwise your material, open your material. There are so many. Control bisection method. Bisection method. Bisection x minus cos x. 3 plus sin x. Shall we try for 3 plus sin x? Same. I want to take another. 3x minus cos x minus 1. Somebody commented 3x minus cos x minus 1. 2 sin x minus 3 sin x. Okay. 2 sin x minus 2 sin x minus 3x. Okay. 2 sin x minus 3x. 2 sin x minus 3x. 2 sin x minus 3x. 3 star x. I'm saving this first. Before 17 you can send before 17.7. Okay. Now we run this program. We can run this program. Now I need a comma b values. Okay. So I need a comma b values. You have to choose a comma b value such that f of a is greater than 0, f of b is less than 0. Okay. Now I run the program. F of 0, that is 0. Root is 0. Already root is there. For this one, directly f of 0 is 0. Okay. Okay. One of the roots is 0. F of 1. I don't want this one. Minus value. F of 2 minus f of 3 minus f of minus 1, f of minus 2, f of minus 2, positive. Only one root is there, I think, for this function, x minus 3x minus sin x. It is a positive, f of minus 2, f of minus 3. it is increasing. So 3x minus sin x has only one root at x is equal to 0, I think. 2 sin x minus 3 sin x. Why? Because this is equal to 0, sin x is equal to 3x by 2. This maybe it is only one root, I think. That is x is equal to 0. It is increasing. F of minus 2 is decreasing. F of 1, 2, 3 are negative. 2x minus. Need to understand my point. F of minus 3 minus 10. Is a negative, positive will come. It will increase. So minus 10. Why? Because minus 3x we are taking. This plus it is coming. It values sin x value lies between minus 2 to plus 2. We are adding big values. So it definitely it will be positive. If you take a negative value, it will be positive. If you take positive value, it will be negative. If you take a positive value, it will be negative. Positive value, this will increase. Only one root is there. So it took, that is x is equal to 0. You take another function. Tell me another function. 2 sin x minus 3x has only one root, that is x is equal to 0. No need to apply bisection method. Directly we got this value. Okay. Tell me another function. Others. Anyone? Any other functions? Okay, 3x minus cos x minus 1. I will take this one. Okay, 3x minus cos x minus 1. Three x minus cos x minus. Otherwise, you take a cubic equation. It's not a problem. Run. I want to find out the root of this one. Okay. What is f of 0? F of 0 definitely minus 2. Why? Because f of 0, this is 0, cos 0 minus 1, cos 0 1, minus 1 minus 1 minus 2. F of 0. F of 1, positive. Root is lies between 0 and 1. Root is lies between 0 and 1. F of minus 1, for example, was negative. Okay. Root is lies between f of 2. We take f of 2 other way. F of 2 is positive. So f of 0 is negative. F of 1 is positive. Now we choose a is equal to 0, b is equal to 1. Root is lies between 0 and 1. Okay. A is equal to 0, b is equal to 1. B is equal to, the most important, we have to remember this one, C value. F of A greater than less than 0. F of B greater than 0. We take a percentage symbol, these statements will not be executed. Now we have to take C value. C is equal to A plus B by 2. A plus B by 2. So this also here we take if f of C greater than 0. What is the condition? F of C is greater than 0. What we have to do? If f of C is greater than 0, B is equal to C. Am I correct or not? Else A is equal to C. And if f of C is greater than 0, if this function value at C greater than 0, I have to replace. I have to write C value in the place of B. Otherwise, that means f of C is less than 0, I have to write C value in the place of A. So in the first iteration, my root value is Okay. In this case, my root is in the first root 1. Root value. Root is root 1. Root 1 I am giving. C. In the first iteration. Okay, I am running this one. What will happen? Root is 0.5. Am I correct? So what is that? Why? Because in the first iteration, this loop I have to repeat number of times. Okay. What is the function value at C? F of C or F of C or F of root, both are same. Am I correct? Root 1 or F of C are same. Minus 0.3776. Function value at 0.5. The function value at 0.5 is negative. But this it is not close to 0. It is minus 0.3776. It is not appropriate root. So you have to repeat this loop. Am I correct or not? I have to repeat this loop. I don't want this one. This entire thing I have to repeat. How to do this one? 3 or 4 times you have to repeat, or 10 times or 15 times you have to repeat. How to do this one? Tell me, anyone. I have to repeat this process. I have to repeat this process. Anybody? I have to these steps I have to repeat certain number of times to get a desired root. Where I have to take a for loop. Anybody? Any comments? Did you understand my first? You understand for loop? Tell me how to write the for loop. Where I have to write the for loop? Tell me. I given one method I have given on the left hand side. You can see, but I don't apply that method. I will write in different method. But I will write in different manner. Okay, something I wrote here. Okay, it's every time it will be changed, but have to get. Okay, I think you hope me understand. Okay, every time I have to calculate C value. Am I correct or not? So I have to start from this point. For loop is equal to 1 colon 10 times. I want to repeat this loop. I have to end here. Now you see this one. For I is equal to 1, I will MATLAB calculate C value. Okay, MATLAB calculates C value, that is a plus b by 2. It calculates f of c is greater than 0 or not. If f of c is greater than 0, it calculates f of c. F of c is greater than 0, then it replaces, it takes as a c value as mu b. Otherwise, it takes a value as c. And it will continue again. Now c value came. Already a is there, b is there now. New a, new b came. Okay. Okay, C is equal to A plus B by 2. Again, it will check. This loop will be repeated how many times? 10 times. And finally, we will get a root. That is, root value is C. My root is C. My root is C. Okay. I'm running this program. What will happen? Root, what is the root value? Root is 0.6064. What is the function value at root? This f of root minus 0.0023. No, 0.0023 means it is not an appropriate root. So I'm increasing the iterations. I'm taking 20 iterations to run this program. Root is 0.67 f of root. That is 2.6636 into 10 to the power of minus 6. That means 0.000006636. It is almost equivalent to 0. So we can take this as a root. Otherwise, you want it take more iterations. 30 iterations. What is it? 30 iterations. I will do all the things. What is the function value at this root? -11. That means 0 0.00. 8, 9, 10, 11, 10. 4, 1, 0, 5, 7. So format long means you will get a root value. Format long. Root 0.6, 0.607106148 like this. It is displaying up to 4 decimal places. Okay. That's the thing. Format. My root is this one. Function value at this root is this. Now the next thing is I want to change this small, I want to make small changes in this program. Next thing is each iteration I want to store the root values. So f of I, not f of I, not f of I. Root values at C. Okay. At each iteration, I want to calculate the function values. Okay. F underscore B and generating array is equal to f of B is equal to, otherwise we take function. I am creating an array. Each iteration value, for each iteration, first iteration value, function value, I, f of I is equal to f of C. I am calculating C value, the function value I am calculating. First iteration I am storing in f of VA. Did you understand my point? For at each iteration, I am calculating the function value I am storing in f of A. That I did here in this one, in this slide. F of C. F of C value I am storing in an array. I. That means f of 1, it is an array. F of 1. F of 1. The function value I am storing f of 1. Next iteration, new C came. That I am calculating the function value I am storing in second place. Third iteration, after third iteration, after second iteration, I am going to third. In the third iteration, I am calculating C value again, and the function value I am storing in third place. Okay. So after 30th iteration, this array contains 30 function values. F of 1, function value at first iteration, function value at second iteration, function value at third iteration. So this is the root, my root. Am I correct? The difference, error in each iteration. Error in each iteration is nothing but f of f underscore of vi minus final root f of c. This is my, I'm assuming this as function value at c. This is the root value. This is root value at final iteration. This f of v contains the function value at each iteration. This is error. Error in each iteration. Okay. I want to plot this one. Plot error. Run this program. Error. Why not came, but new problem. FVA is correct only. FVA minus f of c is correct only. We'll take less iterations, maybe. We'll check first 10 iterations. What is c value? Root value. C is equal to 0. Of c. An iteration correct only. Why is wrong error is not coming? Any mistake? F of I is equal to f of c. Each function value I'm rotating. Okay. Error is equal to is correct. Plot error is also correct. It is not. Any mistake is it? Error values is not coming. F of vi, f of c. Otherwise, the root time taking root. Not a problem. It's not a problem. No, it is not. F I take it. Sorry. This is f of I have taken. Last value minus last value. It is okay. F of I. Okay. This is error. Okay. Ith value. 14th value I have taken. It becomes 0. This is f of v I have to take. F of v and underscore v. Array. Function value at the first point. Array. Function value at first iteration. Function value at second iteration. Function value at third iteration. Function value at fourth iteration. Function value at fifth iteration. Function value at sixth iteration. Function value at 7th, 8th, 9th, 10th. These are the iteration value. What I am doing, f underscore v minus f of c. F of c means last, this is I am assuming this is the root, final root, f of c. So this is the value, these are the values. These are the errors in each iteration. Are you understand my point? You understand my point? This is error value at each iteration. Okay. Last value I am assuming as root, it will become 0. I have taken f of I. F of 14 minus 14, it will become 0. 0 was plotted in the previous one. That is the thing. Okay. This is the. Now actually in this one, in this one, if you take more values, more iteration values, 20. This is the first iteration difference. This is 0. It is approaching almost equal to 0. We take a grid down. Can clear. Yes, I am plotting error. Errors, that's it. Nothing is there. Nothing is special here. It is not necessary actually. This is the first iteration. First iteration function value minus my assumed root. 30th iteration function value difference. This one. This is second iteration value minus second iteration function value minus function value at the last iteration. This is third, fourth, fifth, sixth, and so on. Okay. Now, C is this one. F of C is 2.6636 into 10 to the power of minus 6. So this is all these are not necessary here. All these are not necessary. These points. This point is not necessary for us. This is also not necessary. This is also not necessary. These are the extensions. This is also not necessary. This is also not necessary. This is the main program. Okay. Close means all figure windows will be closed. Clear. I am taking these not all. These also not necessary. Next thing is, can we write this as a function format? Can we write this as a function format? Run. This is the root. This is C is my root. Output is my C. Okay, root. I want to write it as a function format. I want to write this function in this entire program in function format. How to write that one? How to write this? Delete. F is already there. Function already F I have used. Function G is equal to function name. What is the function name? B41712 of what are the input values now? Tell me what are the input values here? What are the inputs you have to give to find bisection method? What are the inputs you have to give? F we have to give. Am I correct? F, comma, A, comma, B. These are my inputs. If you give these inputs, this is not necessary. If you have to prove this one also. Am I correct or not? Now, the advantage of this function is this value we can use in another function. If we write a script file, answer will be displayed in the command window. That value we cannot use in any other function. That value we cannot use in another function. If you want to use this function root value in another function, you have to create in a function format. You have to write in a function format. Now this is the function format. Okay. So what is this a value? If you want to run this program, you have to choose a value in such a way that f of a is less than 0. F of b is greater than 0. Okay, now I am running, so now I am saving. If you run this program, it will show error. Why? Because there is no input values. A, I haven't, A is A, I suppress it, B is also I suppress it, F also I suppress it. Suppose if you want to run this program, B4, Control C, Control C, Control V, F, at the rate of x, at the rate of x. What is the function? 3x minus cos x, 3x minus cos x minus 1. 3x minus cos x minus 1. What is a value? A is the most important point is A is less than 0. The next program you have to write very carefully. A is 1, B is equal to A is equal to 0, B is equal to 1. A is equal to 0, B is equal to 1. If you run this program, you will get C value. What is C value? 0.67. Here also, if you want to get the direct answer, you have to change small thing. Here, the root value, we should not write like this. What is the output? G is equal to C. Output value. G is equal to C. Now directly answer will come. Save this value. Answer is 0.6071. 0. Output. This is the output value. G is the output. Output value. See, G is the output. This is the input values. I am storing the root value to output. Here, if you want to, these things will work in the program. If you want to get a plot, you can do this. Save. Okay, to run. Oh, something. 14. F of V. F of V. Undefined functional variable. F of V. Root, not root. C. Am I correct or not? C. Am I correct? C. Like this. We'll get plots and all this automatically will come. There is no need to ask, display the plot and all this in files, M files. Okay. This. Now I want to take a new function. I want to find out a new function. For example, I'm taking a cubic third order equation like tell me one equation. Tell me one transcendental equation. Shall I take x2 minus 3x square, something, 3x square plus 2x plus 2. The roots are there or not? Real root, that is very important. Roots are there or not? I will check. The function should have real roots. Roots, no? Roots of 1 minus 3, 2, 2. Okay, one real root is there. Two complex roots and one real root. Minus 0.5 to 1,4. Okay, that's fine. Roots are there. Now I'm defining a function. F is equal to at the rate of x cap 3 minus 3 star x cap 2 plus 2 star x plus 2. That's my function. Okay. See this. This is my function. F of 0. I'm starting with f of 0. Positive. F of 1. F of 1 is also positive. F of 0.5. Root is less between the of 0 and f of 1. F of minus 1. Minus 1. Negative. F of minus 1. Root is less between minus 1 and 0. F of 0 is 2. F of 0 is 2. F of minus 1 is minus 4. Okay. What is the A value here? According to my function, according to my file, f of A is less A at A less than 0. That means which value I have to take A? I have to take A as minus 1. Am I correct or not? A is equal to minus 1. B is equal to 0. Am I correct or not? According to my file, f of A is less than 0. A is my f of A is less than 0. A is equal to 0. F of A is less than 0. We should not take A is equal to 0. Am I correct or not? You have to take A is equal to minus 1. At minus 1, function value is minus 1. So A is equal to minus 1, B is equal to 0. A is equal to minus 1, B is equal to 0. And function is this one, B4. Okay. That is the thing we have to do. We have to decide. And we have to go for this M file. What is my function? X cube minus 3x square plus 2 star x plus 2. What is A value? A value 0 na? A value minus 1 na? I forget again. What is A value? A value minus 1 I think. Minus 1. B value 0. B value 0. My root is 0.5214. That's it. This is the function to calculate root using bisection method. Okay, so this value you can use anywhere in this, anywhere in the MATLAB program, any MATLAB program, any MATLAB. So I want to find out a root of a transcendental equation. That root value I use in another function. So in that case, this function format will be very useful. I hope you understand this technique. So every program I am telling in script file and as well as function file, function format. Okay, before 1712 is a function to find out root of a transcendental equation using bisection method. Suppose if you I want only the root means there is no need to write by function format. If you want to use that bisection method root value in somewhere in the in another file in another file in another file, you have to use this one. Okay. So for example, sign off. For example, this is there. Something I'm telling. Sign off. Sign off the root value is not only here. We can use the previous function also. If it is relevant, I will tell you. My another function, some functions yesterday I created one file. Yesterday before 03. What is this? It should be relevant. No, it is not at all. Yesterday some files I created before. What is this one? No, this. I will tell. If you create some more 2 or 3 M files, you can use one M file in another M file. What is this one? No use. No, if you, I will tell you. This is not a big issue. Politics, performance, 18 plus. Okay. Okay. If we create 2 or 3 M files, we can easily understand. Any doubts on this function bisection method and function format method? Plot contains 2 parameters. There is no need. Plot contains for single also you can plot x comma y, not necessary. Suppose I want to plot x is equal to x is equal to 3, 4, 6, 8, 9. For example, it's my x. Give plot x. To give the plot x value. Again. At x is equal to, it takes 1, 1, 3, 2, 6, 3, 3, 4, 7, 5, 9, 5, 5, like that. Okay. Oh, no, 6, 5. So 1 at 1, function value is 3. At x is equal to function value 6. At x is equal to 3, function value 3. At x is equal to 4, the function value is 7. Otherwise, you give plot. First value, second value, third value, fourth value, fifth value, sixth value. If you give like this, it will take 1, 2, 3, 4, 5, 6 values. It plotted 1, 3, 2, 6, 3, 3, 4, 7, 5, 9, 6, 5. Okay. No need to take 2 arguments. We can close by single argument also. Any doubts? Next. Sir, any doubts? No one is. Similarly, suppose you want to find out another method. So one method is enough to find the root. So no, actually, so suppose if you take the most important thing is here, most of them are mathematicians. If it is not a continuous function, bisection method is not applicable. But secant method is also not applicable. Not applicable. Best example, x minus tan x. If you take x minus tan x, it is a discontinuous function at x is equal to pi by 2. You take this simple function and take CLC x minus f is equal to at the rate of x. We used to tell this example for students. X minus x. We cannot find it. We can find a comma b in such a way that f of a is positive and f of b is negative, but we cannot find the root. So, for example, f of 0, what will happen? If f of 0 is 0, sin 0, f of x minus 10x, f of 1, for example, another pivot, okay, f of 1. What is f of 1? This one, positive. Okay. F of 2, negative, positive. F of 1 and f of 2. Okay. So, this is a f of 1 is negative, f of 2 is positive. Suppose if you plot a in between these two values, we can observe this value. X is equal to min space 1 comma 2. I want to see the plot. Y is equal to x minus 10x. Minus 10x. Plot x comma y. There is a discontinuity. F of 1. So the image of f of 1. F of 1 is some value 0 point something. It is a if you start this function, I will apply this method. This is a discontinuity at x is equal to this point. Okay, there is a discontinuity. At this point. So, but we cannot find the root. I will tell you how, because you see this one. I will proceed this function with this value. F of a is negative, f of b is positive. Okay, you see this one. I am calling the same function now. What is the b4 function? You cannot find the root for this b4. Where is b4? This one. Not sign. I will remove the sign also. X minus tan of x. What is f of a? My b4 function f of a is positive, f of b is negative. b4 I have to open. B4 f of a is less than 0. F of a is less than 0. A is equal to 1. F of b greater than 0. B is equal to 1 to 1 to 1. So it will give some value, no doubt. Okay, it will give some value, but the answer is 1 point. Root value is 1.5708. What is the function value at C? A function value at ANS. You see this one, minus 3.1856 into 10 to the power of 6. 10 to the power of 6. It is at 1.5708. How many iterations have taken here? How many iterations? 20. After 20 iterations, the function value is increasing. Minus 3.1856 into 10 to the power of 6. Now I will increase more 21 iterations. What will happen? I will take one more iteration. 21 iterations. Okay. 21 iteration. I am saving. It is coming 1 point. Function value at answer. 10 to the power of 6 positive it came. You see the beauty of this one. Here negative 10 to the power of 6, positive 10 to the power of 6. This answer is 6. Function value at this point. Function value at this point 6.13800. 61 lakhs 38,000 around like this. No, like this. 1, 2, 3, 4, 5. Okay, 6. One more zero will come. 61 lakhs 38,000 value, function value at that point. Here the function value is minus 31,000, 85,000, 85, 31, 31 lakhs, 85,000, some 600 like this. Did you understand my point? So we cannot find the root for this function because it is a discontinuous function at x is equal to pi by 2. X minus tan x is, that's why I plotted first. That's why I plotted. So this intermediate value, first condition is very important. If f of x is continuous, then only we can apply bisection method and or secant method or Newton-Raphson method, whatever. This is the value. See this one. In space, this one, 1 comma 2, x minus tan x, plot x. See this. This is the behavior of the function. Grid on. And there is a discontinuity at this point. As x approaches to some values, there is 1.57. Maybe it is pi by 2, maybe. This may be 1 pi by 2 or pi by 4 tan x is equal to x. Okay, this is a discontinued point at this point. Otherwise, you take a tan x, you take an interval minus 1 point close to pi by 2, left hand side, right hand side, some interval. You cannot find the root. It is a discontinuous function. It is going like this. It is going increasing like this. It is a discontinuous function. That's why we are unable to find the root, even though f of a and f of b are opposite side. F of a and f of b are in opposite side. Okay. So if you have any doubts, you can ask. Did you understand this logic? Otherwise, I will. If you have doubts, you can ask. So programming is a boring topic, no doubt. But at least we should know the basics of the programming. I know the programming is very boring. I will take some my interesting topics and I will explain. I will write a program.
Sir, number of iterations are increased, sir. Means what, sir? I didn't understand that one. In bisection method.
Number of iterations are increasing means, so first iteration, second iteration, third iteration. If you increase more number of iterations, if you repeat
Sir,
more.
for C-value calculation, one doubt, sir. For C-value calculation, we are taking the alternative positive and negative value, na, sir?
Yes.
In bisection method.
At A, first I am taking at A, f of relative, this is a function value at A is positive, function value at B is negative. Okay.
Yes, sir.
Later in the next I calculate C value. C is equal to A plus B by 2.
Yes, sir.
So at this point I calculate the function value. If it is positive, I have taken this value as A.
Yeah.
This as B. Again I calculate C value, middle value.
Yes, sir.
At this point, function value is negative. So this I have taken as.
That is not my doubt, sir. How can we increase the iterations, sir?
Iterations, number of iterations, we have to increase we have to repeat these steps. There is a number of iterations. This I am taking A.
Sir, when we are getting a positive value, we are changing the positive number A or B value. When we are getting the negative value, we are changing the A value. When we are getting the positive value, we are changing the B value. It's the process for the bisection method. Then
Yes.
how can we increase that iterations?
How can we iteration means if you want to find out if you want to know the accurate value, if you want to know the accurate,
No, sir. That process will take only fixed number of values. Means we cannot manually increase, na, sir.
No, that process is not a fixed values. We can do any number of times. We can do 100 times, 200 times, 200 iterations. 300 iteration, 400 iterations also. If you want to get accurate root, accurate means very close to zero. We will increase more number of times. We'll repeat the loop.
No, sir. Uh, while I am teaching in the bisection method, maximum it may take 30 to 40 iterations.
No, you can
Max.
take 100 iterations also. What is the problem? What is it? So 30 iterations we can take. 40 also we can take.
At that
Okay?
point only, it will get 0.0000 something we will get, na, sir.
I see.
Why we will increase that iterations?
While increasing the iterations, we get, I'll tell you, for example, you see this one. This is my best example. Okay, na?
Uh-huh.
This
Yes,
is
sir.
you see this one. First, see this. I don't want all these values. My idea is I'm closing all this. No, for our discussion, this is not necessary. Comment. Okay. This is also not necessary. Because every time plot will come. So I'm starting it. Just 10 iterations I complete. 10 iterations I have taken. Okay.
Yes, sir.
Before f 3x minus cos x. Any function. Now we take this is the x minus. Answer is this function. F of function value at this root
Yes, sir.
minus 0.0455.
Yes, sir.
So it is not my desired root. It is not close to 0.
Okay.
0.0455. Am I correct?
Yes, sir.
Yes. Next, I'm taking 15 iterations.
Okay.
Run. No, now we should not run. Save. Am I correct or not?
Yes, sir.
So this is the we should not save. Already saved. Run and save. Now I'm running this code. Now the root is minus 0.4981. This is 4973. What is the function value of this answer? 0.0457. The previously the answer is 0.455. Here 0.457. It is also not a correct root.
Yes,
Now
sir.
you take 20 iterations. Save. I am running the same program. The root is minus 0.4981. It will actually the answer if you take more format like it will come. Still it is 0.45 0.45 0.457 only. Okay. Now 20 30 iterations. Say 0.4981. So any wrong, we'll check it. Wait. Just wait. Any wrong is there? G is equal to 30. Same value it is coming. Wait.